All right, section 3.3. Now we get into what I would call the meat and potatoes of the section, the adding and subtracting of unlike fractions. So only like fractions can be added or subtracted. So remember, those are the ones that have the same denominator like we saw in 3.1. So what do we do if they're unlike then, if they have different denominators? Well, we make them into like fractions. So if you want to add or subtract fractions, first, you're going to rewrite the fractions being added or subtracted as equivalent fractions, just like we did at the end of 3.2 when we were comparing fractions. So we're going to write them with the same denominator. You can use any common multiple of the denominators, but the lowest common multiple or lowest common denominator, same thing, is a good choice. Then you're going to do the same thing you did for like fractions. So numerator plus numerator or numerator minus numerator, depending what the question asked. Denominator always remains the same. And then finally, you want to simplify if you can. So just a reminder, the least or lowest common denominator is just the lowest common multiple of the denominators. So in this first example, our denominators are 5 and 2. And so 10 is going to be the lowest common denominator of those two fractions. So, and I kind of gave away my punchline, didn't I? All right, well, so we've got these two unlike fractions we want to add. We want to add 1/5 and 1/2. And just visually looking at it, it would be hard to do, right? It's hard to imagine that. So what we need to do is write them both as equivalent fractions. And I'm just going to do it on the side here. So we've got 1/5 and 1/2. So we're going to find the common denominator or lowest common multiple of 5 and 2. Well, we said that if our two numbers are both prime like they are here, the LCM or LCD, since these are both denominators, is going to be the product of them. So here, the least common denominator is 10. So that means what we're going to do is we're going to represent these two fractions. We're going to find equivalent fractions that represent the same amount of stuff that are over that LCD. So for this first one, 1/5, we want to express that as some number over 10. So we ask ourselves, well, what did we have to multiply the 5 by to get to 10, or to get to 10? And we had to multiply by 2, which means up on top, we're also going to multiply by 2, giving us 2/10. Same thing for this other fraction. So 2, we had to multiply by 5 to get to 10. So we're going to multiply our top number by 5 as well. 1 times 5 gives us 5. So now we have our two fractions expressed as equivalent fractions with that LCD. So what we're really adding then is 2/10 plus 5/10. And that's way easier to do because now we have like denominators. Our denominators are the same. So we're going to do numerator plus numerator, which gives us 7 over that same denominator of 10. Last step would be to check if you can simplify. In this case, we can't. So our final answer then is 7/10. And here down below, you see this picture. They've shown us a visual representation of that. So where we have that pink 1/5, now that the circle is divided into 10, you can see that's 2 of those 10s. The 1/2 circle, now you can see that looks like 5 of those 10s. So it makes sense now that the entire amount, once you add it, would be 7/10. Okay, let's do some practice. And these really do take a lot of practice. So first thing I'm going to do is find my LCD. So my denominators are 6 and 8. So I think this time I'll do the division method, but you can do the trees if you prefer. So 2 is a prime factor. It's common to both of those. That leaves me with 3 and 4. There is no common factor of either of those, but I know I can divide the 4 by 2 to get 2. 3 is already prime, so it just comes along for the ride. And now I can draw my L here because I only have prime numbers in my L. And so my LCD here is 2 times 2 times 3 times 2, which is 2, which is 4 times 6, so that would be 24. Okay, so that means I want to write each of these fractions as equivalent fractions over 24. So we've got 1/6. Maybe we'll just do it in the side here. We've got 1/6 We want that to be some number over 24. We have 3 over 8. We want to convert that to an equivalent fraction over 24. So for that first one, what did we have to multiply to get from 6 to 24? Here we had to multiply by 4. So that means on top, we're also going to multiply by 4, leaving us with 4 over 24. Same thing to that bottom one. So this time we had to multiply by 3 on the denominator to go from 8 to 24. So we're also going to multiply our numerator by 3 to get 9 over 24. So that means 1 over 6, we just said, is the same thing as 4 over 24. And we're adding it to 3 over 8, which we said is the same thing as 9 over 24. Now we have like fractions. So we can go numerator plus numerator. 4 plus 9 gives me 13. Denominator stays the same. Last step, ask if you can simplify. Here we have no factors in common. So 13 over 24 is my final answer. All right, let's try the next one. Here our two denominators are 5 and 15. Okay, well, actually, there's a way to cheat on this, but let's do this the old-fashioned way. 5 prime factorization of 5 is just 5. 15 is 3 times 5. So if I write my prime factorization table here, 5 gives me 5. 15, I've got a 3, and then I've got a 5 that'll line up there. So my least common denominator here ends up being 15. A shortcut approach I could use too is one of my numbers, the 5, it's just a multiple of 15. And so you know that your lowest common multiple in this case is going to be the 15. Okay, let's figure out our equivalent fractions. So we want to take each of these fractions and figure out an equivalent fraction over 15. So pause the video and see if you can think of equivalent fractions. Well, that second one's actually done. So think of the equivalent fraction for 2 over 5. So what number would it be over the 15? Okay, and hopefully you had a chance to do that. So we've got 5 times 3 would give us 15. So on top here, we're also going to multiply by the 3 to get 6. So 2 over 15 is the same thing as 6 over 15. And then I'm adding another 4 over 15. Now I have like fractions to add. So I add the numerators for 10, keep the same denominator, and then I simplify if possible. So here, both of these are divisible by 5. And remember, I could figure out the GCF if I want. You'll find it's 5. And that'll tell you what to simplify by. And so this is going to give me 2 over 3. So my final answer here would be 2 over 3. Let's do a couple more together. So next one, so again, just on the side, I want to find my equivalent fractions here. I've got to figure out what my common denominator is. So let's do division method again. So I've got 10, 15. Both of those are divisible by 5 to give me 2 and 3. And that was easy because they're already prime. So I draw my L. My least common denominator here is going to be the product of those numbers circled in the L. So 5 times 2 times 3, which is 30. So I'm looking for equivalent fractions that are over 30 here. So give the video a pause and see if you can figure those out. All right, let's do them together. So 10 times 3 gives me 30. So that means on top, I'm going to do 7 times 3, which gives me 21. And then on the bottom here, 15 times 2 would give me 30. So on the top, I'm also going to multiply by 2 to get 4. So this addition of these two fractions is the same thing as 7 over 10 is really 21 over 30. And 2 over 15 is the same as 4 over 30. So when I add those two like fractions together, I get 25 over 30. And final step, I want to see if I can simplify it all. Here, I know I've got a 5 in common, so let's divide that out. And that's going to give me 5 over 6. 5 and 6 don't share any prime factors or any factors, so we know we're fully simplified. So why don't you take a look at the next ones? And then so give them a try and then come on back and watch the video.